Hey everyone, I'm Tarun and I want you to integrate this. Quick, pause the video, give it your best, use that beautiful brain of yours, and if you get it, tell me in the comments, but do try, okay? I found this question in MIT Integration B. They host these integration competitions. They have some good questions, you should check them out. You can check them on YouTube. Right? I hope you paused the video and tried it for yourself. Now I'll show you what I thought about this. I found two really nice and interesting ways to do this. Okay. I'll go to the first one. The first one is, okay, what I did was I added 1 and subtracted 1. So that became e to the power 3x plus 1 minus e to the power x plus 1 and so on. Right? So that's what I did. That yielded me this 1 by x into e to the power x plus 1 minus 1 by x into e to the power 3x plus 1 dx integrated from 0 to infinity. Right? Now I can break that into two integrals by writing it as this. Oops, infinity. Okay, now here's my first method. I define a function I of n such that I of n is equal to 0 to infinity integral of 1 by x e to the power nx plus 1 dx. This is what I defined I of n as. Now I'm going to do something and I want you to think about why that is true. Okay, therefore from this we get I dash n. I dash n is the differential of I of n with respect to n. So I'm differentiating it with respect to n. I'll get I dash n is equal to d by dn of whatever this integral gives. It will give us something in terms of n, I feel. Won't it? Something in terms of n. X is varying from 0 to infinity, so that will vanish after the integration happens. N will remain. So this integral is a function of n. That's why I denoted it as I of n. So I dash n will be d by dn of blah 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 dx, right? The important thing is I'm going to erase this d by dn and put it inside. I want you to reason why I might have done that and why that is correct, why that doesn't change I dash n. This is equivalent to the d by dn were outside. Think about that. Okay, so I dash n becomes, let me write that bigger, it becomes 0 to infinity d by dn, okay, 1 by x into e to the power nx plus 1 dx. That's what I dash n is. Now, n and x are constant with respect to each other. So I can just take x out, okay? Also, what I'm doing is, I'll write e to the power x as a to make things look simpler. Right? E to the power x I'll write as a and I'll take x out. So what will that give me? I dash n is 1 by x, right, into d by dn 1 by a to the power n plus 1 dx integrated from 0 to infinity. Right, got this? Okay. I need space, erase the top. Okay. So I took I of n as this, I differentiated it with respect to n and got this result. So let's remember, I of n is 0 to infinity 1 by x e to the power nx plus 1 dx. E to the power x I have written as a. Okay, so when I differentiate this with respect to n, I get I dash n is 0 to infinity 1 by x. I'll apply chain rule here. I'll get minus 1 by into minus 1 by a to the power n plus 1 the whole square into d by dn of a to the power n plus 1. And we all know that is a to the power n ln a dx. But recall, a is e to the power x, right? So I can write a to the power n as e to the power nx, e to the power nx, and ln of a as ln of e to the power x, which is nothing but x. So the x's cancel out, the x cancels out, and if you notice, the x is what is causing the problem. So by differentiating I of n like this, we've gotten rid of x. Now how does that help us? What I'm going to do now is I'll take e to the power nx plus 1 as t. My idea is to integrate this function, right, and get I dash n in terms of n, and then I'll integrate that to get the answer. That is my aim. Okay, so I'm taking e to the power n x plus 1 as t. Let me differentiate on both sides. I'll get n e to the power nx dx is dt, right? So if you notice, if I rewrite this in terms of t, right, this e to the power nx dx will become dt by n. One minute. This will become dt by n, and this will become minus 1 by t square. Right, I'll erase this also. So I dash n becomes, let's look at the limits now. If x is 0, then e to the power nx will be 1, so t will be 2. And if x is infinity, then t will definitely be infinity. So that becomes I dash n is 2 to infinity minus 1 by t square into dt divided by n. This n I can take out of the integration because it's constant with respect to t. So we get minus 1 by t square dt integrated from 2 to infinity. Now we all know how to integrate this. This is nothing but this is nothing but 1 by t. So that's 1 by n into 1 by t going from 2 to infinity. So that will become 1 by infinity minus 1 by 2. 1 by infinity can be is 0. So therefore I dash n is minus 1 by 2n. I dash n is minus 1 by 2n. Okay? Great. I dash n is minus 1 by 2n. Can I write this as d of in by 2n? D of in by n, by dn, sorry. Yeah. Okay. Therefore d of in will be minus dn by minus half into dn by n. That's how I write. Minus half into dn by n. Let me integrate on both sides. Now notice what I am doing. I am writing din in which, okay, n goes from 3 to 1. Therefore in goes from i3 to i1. Therefore n here will go from 3 to 1. That's what the limits will be, right? So I will get I of 1 minus I of 3 is equal to minus half ln of 1 by 3, which is nothing but ln of 3 divided by 2. Now you'll ask, what have I calculated here? What is I1 minus I3? If you notice carefully, this thing, do you remember I split it into partial fractions and wrote it as 1 by x e to the power x plus 1 dx minus 1 by x e to the power 3x plus 1 dx? That was nothing but I1 minus I3, because I of n is 1 by x e to the power nx plus 1 dx. That was nothing but I1 minus I3. This is I1 minus I3. So basically we had to find I1 minus I3, and that's what we've done. It's equal to half ln of 3. Right? Now this involved a technique called parametric differentiation or something, right? So this is still a little bit advanced. With the next method I will show you, I believe you'll like that much more, because it's really simple, right? So this is one way to get the answer. The second way is, I'll write it as partial fractions again. 0 to infinity 1 by x e to the power x plus 1 dx minus 0 to infinity 1 by x e to the power 3x plus 1 dx. Right? Now a lot of people, what they do here is, they'll say, let me put 3x as t, right? They'll say, let me put 3x as t over here, right? So 3 dx will be dt, right? And x will be t by 3. So after writing this in terms of t, they get 1 by t e to the power t plus 1 dt. The 3's cancel out, they get this only. They get this, and if you see the expression here is also the same. And they'll say, if 3x is t, x goes from 0 to infinity, that means 3x also goes from 0 to infinity. Therefore, this is also the same, and this is also the same, right? This is also 1 by t e to the power t plus 1 dt from 0 to infinity, and this is also 1 by x e to the power x plus 1 dx from 0 to infinity. So they cancel out and say that the answer is 0. But the answer actually is not 0. You can see clearly that e to the power 3x is greater than e to the power x. This expression is always positive for x greater than 0. So how can this be 0? There is an error in this argument. If you want, pause the video and think about what the error is. This seems so logically correct, but still there is some error here. Can you think of what that might be? I'll tell you. The error is 0 and infinity. Both are numbers which cannot be entered as an input. Infinity is not a number, you cannot input infinity, right? And 0 is not in the domain. If you put 0, it becomes 1 by 0, which is not defined, right? So this is an improper integral. What we do in that case is, we write it as integral of 1 by x e to the power x plus 1 dx from h to n, right? From h to n, where h tends to 0 and n tends to infinity, right? Okay, cool. And here what do we do? Okay, here also the integral goes from h to n, 1 by x e to the power 3x plus 1 dx. Now what I'll do is, I'll multiply this by 3 and this by 3, right? And take 3x as t. What I'll get is h to n 1 by x e to the power x plus 1 dx minus 3h, because I took 3x as t, 3h to 3n, right? 1 by t e to the power t plus 1 dt. Okay? Now here's what I'll do. I will write this as, do you know that integral f of x dx from a to c is equal to the integral of that f of x from a to b plus integral from b to c. So I'm going to use that here. I'll write n here, which was originally 3n, and then write plus integral n to 3n, right? N to 3n 1 by t e to the power t plus 1 dt. Notice that this is 0 because here n tends to infinity, and when n tends to infinity, and when t is between n and 3n, e to the power t is extremely much larger than n, much larger than n. Therefore, this integral is no match, or fine, that's not good wording. I'll just say that this integral is 0 because e to the power n is much bigger than n. Right, so this is 0 approximate. If you want to prove it more rigorously, feel free to try, but I don't think it's worth dwelling too much time on. Yeah. So, okay, that is 0. What about this? Why have I done this? Now, if I use this minus sign, right, we know that minus integral from a to b of some f of x dx is equal to integral of f of x dx from b to a. Okay, so I'm going to use that fact and switch the limits. That minus becomes a plus, and these limits get reversed. So we get this. This is what we get. Right? So this integral of 1 by x e to the power x plus 1 from h to n, and then from n to 3h. Now notice this property again. We have an integral from h to n, right? And then from n to 3h. So that the sum of these two integrals is equal to the integral of 1 by x into e to the power x plus 1 from h to 3h. H to 3h. Right? So I can write this as, I'll erase the top. I can write this as integral h to 3h dx by x into e to the power x plus 1. Whether it's t here or x here, it doesn't matter, the integral will be the same. So why don't we just replace this with x, right, to make it more familiar, and use this property. We will get that this sum is equal to this integral. The benefit of this is h tends to 0, right? If I ask you what is dx by x from h to 3h, right, where h tends to 0, you will say that is equal to ln of 3. You will not say it is equal to 0 because the interval is just so negligible. You can't say that because 1 by x is huge at that interval, in that interval h to 3h. So even that small width, right, when you multiply it by such a great length, that will give a finite integral. That is the detail that was omitted when we said that, the limits go from 0 to infinity, so they will just cancel out. That is the detail which was omitted. Okay. So here we have an integral from h to 3h, and the benefit is that when h tends to 0, x tends to 0, e to the power x is very close to 1, right? E to the power x is very close to 1. Let me just write this as e to the power x as 1 then, because in the whole interval e to the power x is very close to 1, right? It tends to 1. So if I write that as 1, I'll get dx, the integral is equal to dx by 2x from h to 3h, which is nothing but half of ln 3. So there you go. This method, it only requires very basic knowledge of integration, right? But you can solve this question using that. Okay. So thank you so much for watching. I hope you learned something new from this. Right? Thank you.